Hey everyone, it's Mr. Canfield. We're going to work through this review packet. So here we go. This video should just be R1. So this is a review of derivatives, and I'm just going to go through problem by problem. So our first problem says f of x is x to the fourth minus 3x squared plus the natural log of x minus e to the pi. I like to write natural log in cursive when I'm displaying it because otherwise it looks like an absolute value when I do it. And anyway, so if you remember the derivative of a polynomial, if we were to ignore the transcendental stuff over here, the derivative here is just whatever the x is a power to, you just multiply that by the front number, which is just a 1 here. So 4 times 1 is 4. We call our derivative f prime. So 4x, and then you subtract 1 from the power. Same thing here. So 2 times 3 is 6, but it's negative, so negative 6. And you subtract 1 from 2, and you get to the first power. And then we get to one of our formulas. The derivative of ln x is something you have to just know. Because you don't want to have to derive it every time. At the moment, I don't even remember how we figured this out, but it's true. Oh yeah, I think we figured it out through integration, that's right. The derivative of ln x is 1 over x, so. And then the derivative of e to the x is e to the x, but this is not e to the x, this is e to the pi, which might confuse you, but think for a minute. E is a number. What's pi? A number. A number to a number is just a number. This is a constant. The derivative of a constant is always 0. So that would be our f prime for number 1. All right, number 2. So I'm going to do my recommended method for this, but I'll do a quick shout out to other ways that are frankly mistakes. Some people look at this and they're trying to find a derivative and they go, oh, it's a division, so I have to use the quotient rule. No. All this is divided by 4. That's the same thing as this is all times the fraction 1/4, right? 1 over 4. So I really could pull a 1/4 out front and say this is 5x to the 5th minus 3x to the 3rd plus 7x minus e to the x. And then I could distribute that 1/4. This is like a really long drawn out way to talk about this, but I can rewrite this as 5/4 x to the 5th minus 3/4 x to the 3rd plus 7/4 x minus 1/4 e to the x. I didn't do a derivative yet, but I don't need to use a quotient rule. I can just take the derivative. So 5 times 5/4, and since this is an explanatory video, 5 times 5/4. This is really 5 over 1, right? So you multiply the tops. 5 times 5 is 25. You multiply the bottoms. 1 times 4 is 4. So our front number here will be 25 over 4 x to the 4. And we'll do the same thing here. So likewise, it'll be 3 over 1 times the 3/4. So there'll be 9/4 x squared. Now we have x to the 1 right here. 1 times that is just 7 over 4. And then we get x to the 0. So just recall, x to the 0, anything to the 0 essentially is 1. And I said essentially because there's a weirdness of 0 to the 0, but we're ignoring that for right now. Remembering that anything to the 0 power is 1 helps you most of the time. Then here, minus 1/4 e to the x. So remember that the derivative of e to the x stays as it is, and the constant 1/4 on the front just chills there. So it'll be minus 1/4 e to the x. All right, number 3. 8x squared minus 4x minus 1 So if I'm going to be writing a billion problems in my homework, it's nice to use this kind of formatting. Oh, I didn't write F prime in the last one. Good formatting would be like here. Then we box our answer. You can be like F, and then you can be like F prime if you want, and just write your answer. You can also do that. Like, your homework is yours. On a test, though, you really want to make sure at least your first step is super explicit, and anytime you introduce something new, you want to make sure you include, stuff like that. And this is a one-stepper, but you could make this way worse by reducing the difficulty of the calculus. All you would need to do is take 8x squared minus 4x minus 1 and cube it, which would mean you would need to distribute this into itself a total of two extra times, right? You have 3 of these and you do lots of distributing. You would get a ton of terms. It'd be a nightmare. And then you'd have a polynomial and you just take the derivative. And then we learn the chain rule, which says if you have something in parentheses, you can basically treat this like it's x cubed. What's the derivative of x cubed? It would be 3x squared. But there wasn't an x in there. There was a 8x squared minus 4x minus 1. And then what the chain rule says is you can just do that and then times the derivative of the inside. So 8x squared, the 2 times 8 is 16, minus 4, right, because the x goes away, and the 1 turns into a 0. And so this, you could leave out the times symbol there. This is what you would get for your answer for number 3. Both in my class and on the AP Calculus exam, cleaning this up is not necessary most of the time. Sometimes we're going to need to find solutions to this or do some work here, then we would do that, but it's totally good to just leave it there. All right, so number 4 uses chain rule. F of x is equal to the square root of x minus sine x. And if you're like, what are you talking about? Well, because this is x minus sine x to the 1/2, right? That's what square root means. Square root means the 1/2 power. So, in a new filming setup, I have to, there we go. You just move the camera. I ran out of space on my desk. All right. So, all I gotta do is take this and just pretend it's x to the 1/2, right? So I'll bring the 1/2 out front. X minus sine x, and what would the 1/2 become? Negative 1/2, because we subtract 1 from it. And then we'll multiply that by the derivative of the inside. The derivative of x is just 1, and the derivative of sine x is worth knowing. We have 6 basic trig derivatives that you should just know, and it's cosine. So we took the 1/2 out front, subtracted it, plop. We're not really supposed to end with negative exponents in answers, so let's just take a step and clean this up. Remember that the negative 1/2 exponent is the same thing as flipping that and putting it to the 1/2 exponent. So I could say this is 1/2, right? That's what that 1/2 means. And now this x minus sine x that is on top right now to the negative, I can bring it down below and put it to the positive. X minus sine x to the 1/2. Now what about this? Where is this? Well, what's its exponent? Nothing there. It's a 1 then. So that is still going to be on top. Oh, so I'm going to do 1 parentheses 1 minus cosine, or I can just 1 times that is just that. So you might leave it like that. You might go in and prefer to change this to a square root. If your pre-calc teacher made you rationalize square roots, we don't need to do that. Although if it was a multiple choice question, you might have to, and that's where you would have to go in and multiply the top and bottom by the x minus sine x. And it would clear this out, and you would just have an x minus sine x down here, and you'd have 1 minus cosine times that square root. It's yucky, but all right. Let's see, our next one, number 5. Also, this is the first video of the year for me, so feedback is appreciated. Like and subscribe. No, seriously though, anything that I can be doing in this video to be more helpful, just let me know. Okay, so now we have a quotient, and it's different than in number 2 because it's not just divided by a constant, now it's divided by a function, essentially. So, see if you remember the quotient rule. Like, all of these are, you try it and then you go look it up if you're not sure. How far am I in the video now? 11 minutes in the video, and I just thought to say that. Okay, great job, me. So, for me, the way that I remember quotient rule is, it's similar to product rule, but in the same way that it's similar, because quotient rule and product rule, quotient, product, divide, times. Divide and times are opposites. I remember the product rule is plus. The quotient rule is minus. Since there's a minus here, it matters what goes in the first ones and what goes in the second ones. So for me, what I've always remembered is the first thing is the first thing that you take the derivative of. That's true in quotient rule and product rule. So like, I take the derivative of the top first. So I would do top prime bottom, and then bottom prime top. We're taking turns taking the derivative and leaving the other thing alone. And then quotient rule, remember that we have the denominator squared. Excuse me. So the derivative at top is just 4, because it's 4x. And we'll get the regular bottom just sits there, sine 2x. And then here the top 4x goes there. And you could put the 4x here because multiplication is commutative. It doesn't matter which way we do it. But sine of 2x, you might need to handle that on its own real quick. Well, it's sine with stuff in it. Well, what's the derivative of sine normally? Cosine. So the derivative of sine with stuff in it is just cosine with stuff in it, times the derivative of the inside, which is just 2. So 2 pops out. 2 cosine 2x. Now, on a free response question, I give you full marks for this. This is correct, assuming I didn't make any blunders. But there's a couple things that I would prefer to do to clean this up, to make any future steps I have to do easier. I know earlier I said you don't have to, but let's just talk through these. So here we have 4 and then sine of 2x, so the 4 stays out front. We get sine 2x. Here, I know this red line is annoying. Please let me know. I maybe shouldn't use this paper if I'm gonna write down the middle of it. It's thin. I don't know. I like the narrower paper to do math problems for some reason. The smaller notebooks are fun. So the cosine 2x is like, that trig thing can't mix with other stuff. And also, I'm not writing it. The 2x is in parentheses. Usually when it's this formatting, we can assume that that's in parentheses like that. It's just a convention. It's the way people write it. Okay, my lights went out. The screen still looks good. Let me go turn the lights back on. Oh, hold on. I got distracted. Okay, so the cosine 2x, nobody can mix with it. We got a 2, we got a 4x. So 2 times 4x is 8x. I would put that out front here. And in the denominator, I would write sine squared of 2x. And that's how I'd see that question probably represented, or that answer represented. All right, let me go wave at the lights. All right. Almost done this first page, as in we are now over halfway done this first page. All right, number 6. Let's see, f of x is ln pi x e to the pi x. Okay. The big idea here is pretty simple. We've got a thing times another thing. So we can do product rule for that, right? Product rule says I didn't give myself enough room. That's fine. Product rule says you take the derivative of one, you leave the other one alone. You take the derivative of that one, you leave that one alone. So let's see, what's the derivative of this one? The natural log of pi x. Well, ln pi x. Remember that the derivative of anything like this is just 1 over the stuff, so 1 over the pi x, but the inside has a derivative because it's a number times x. So the derivative of the inside is just pi. Wait, 1 over pi x times pi. The pi's cancel each other out. We just get 1 over x here. That's kind of cute. All right, then on this one, e to the pi x. Same kind of idea, right? We have e to the pi x. Well, what's the derivative of e to the x? It's just e to the x. So it's e to the stuff, right? So it's still e to the same stuff. Yeah, write the same stuff. E to the pi x. But then what's the derivative of the inside? It's pi. So that pi is going to pop out front. So this will be pi e to the pi x. We do a lot of derivatives of e to the x and ln x in this class, or e to different things and ln of different things. So we could clean this up. Let's talk a strategy that you might see on this if it was a multiple choice question. You wouldn't see this as the answer. You have the over x, so that's going to be there. But see how they both, this term and this term, yes, they're both just terms. They both have an e to the pi x. So we actually could pull an e to the pi x out front of everything. And if we do that, here we have a 1 over x left. And here, the pi's left, but that's gone. And the ln is still there. So we could say pi ln. Why did I write absolute values? It's because I was talking about it earlier. Pi x. So this might be another way that you see it. All right. But again, this is perfectly acceptable. And all this is with the caveat that I'm not making any stupid mistakes. So it's absolutely probable, possible, potentiable. All right. So here's 7. For me, my brain, whenever I write a squared, did I do that on the previous page? Am I a liar? Yeah, I'm a liar. So this time I felt like doing that. Okay. So, back when 2 chains was popular, this was a funny joke. Or like when stacks on stacks was a thing, but I don't know. Are either of those things anymore? Whatever. Remember that sine squared 3x is the same as the sine of 3x, the quantity squared. And so this is just a chain-chain problem, right? Look as far out as we can get. Squared. What's the derivative of something squared, or x squared? Well, it's 2, and then the 1 power. And we just leave the inside stuff alone. So now we're done that part. Let's focus on sine of 3x. Well, what's the derivative of sine of 3x? Well, it's just sine of stuff. So the derivative of sine of 3x is just cosine of 3x times the derivative of the inside, which is 3. So this 2 sine 3x now gets multiplied by a 3 cosine 3x. And I would clean this up. I'd see, let's see, I got 2, I got times sine, I got times 3, I got times cosine. So I do 2 times 3 is 6, and then sine cosine or cosine sine. Sine 3x, cosine 3x. A little sloppy there at the end, but yep. And as many nested parentheses as we have, that's as many chains as we just multiply along at the end. All right, 2 more on this page. They look nice and simple, LOL. All right. Cube root of the tangent of x over 3. Okay. So let's rewrite this for conversation purposes, right? This is really, cube root is the same as the 1/3 power. Inside, this is the same as tangent. And then inside again is the same as 1/3 x. I think those rewrites might help you see how easy this actually is. Stage 1, all the way outside, we got the 1/3 power. Okay. 1/3, leave everything inside alone. Leave it alone. And then we subtract 1 from that, so 1/3 minus 1 is negative 2/3. Times. All right, that was our most outside. What's our next outside? Tangent. Well, what's the derivative of tangent? And this again, this is like, you know it, or like it. You're not going to just figure this out. It's secant squared. I was going to write secant squared x. It's not. It's secant squared that stuff, right? And then I can go one more inside. What's the derivative of 1/3 x? 1/3. So we could say f prime is equal to this. We could also say f prime is equal to, I got a third and a third, so what's a third times a third? When you multiply the 1s, you multiply the 3s. That's 1/9. And then you could say tangent, and a lot of times instead of writing 1/3 x, you're gonna see x over 3. I just wanted to illustrate how that x over 3 secretly is just a 1/3 times x, and it's a very easy derivative. Negative 2/3 secant squared x over 3. And so I'm actually not okay with the ending here. I have a negative 2/3. So let's do what we did earlier. Put the 1 in the 9, put the tangent x over 3 to the 2/3 down here. And then up here we have a secant squared x over 3. So there you have it. All right, and the last one for this section, because there's certainly not 23 more questions on the back. All right, number 9. Cool. F of x is equal to, all right, and I have not looked at this formula today, and I want to challenge myself. All right, x inverse cosine e to the x. All right, so what this is going to be, it's x times this. It's a product rule situation. We're going to have stuff cosine inverse e to the x plus x times, wait, what's the derivative? Whatever the derivative of this is. So what's the derivative of x? 1. Okay, so that part's easy. The derivative of cosine inverse, you are not going to just magically know this. I want to say cosine inverse, is it 1 over square root 1 minus x squared? What's our formula say? Ah, it's close. Oh, it's a, yeah, okay. Negative. So negative 1 over 1 minus, oh wait, square root, 1 over, negative 1 over 1 minus, or 1 over square root of 1 minus x squared. So the thing is, I don't have x here, I have e to the x. So it'll be e to the x here, and that quantity squared. So that's the derivative of cosine that, and then we'll do chain rule times the derivative of the inside, which is e to the x. So my guess is that was a little bit of a of an increase in difficulty if you if you weren't already familiar with inverse trig. So I think that is a good place to stop for now, and we'll pick up in the next video. Bye. Oh wait. Bye.